Hello world, I'm Evan Gudmstead, an instructor of application and web development at Rankin Technical College. In this video today, we are going to be building the hello world of AI agents in C#. And so I have this program kind of completed to demonstrate what we will be building. You can see this is a command line application. Again, hello world just getting started with AI agents. And so I can prompt my agent, tell me what you can do. And what we're going to get back is a response from the LLM that says, hey, I have a couple of abilities. I can retrieve a list of lights and I can change the state. I can give like a numeric response, like let's retrieve the list of lights. Already you're seeing some differences between the LLM because I'm hitting a local data set. I'm not hitting, this is a live data set with my database or list. This is not, the open internet. So that's what got me interested in LLMs. Let me go ahead and maybe change one of the light statuses. And again, you can kind of give it text or number inputs. I guess it interpreted number 2 as like, hey, turn the porch light on. I could also say, turn the table lamp on. So it's going to take your text instructions and change your local data set. And so that's the hello world getting started of AI agents. Additionally, a little bit of theory, because if you're like me, you have to kind of learn what is an AI agent anyways. And so I just gave a code demonstration of building an AI agent. The tool that we're going to use is called Microsoft Semantic Kernel. But in order to understand the AI agent, I've had to go through a little bit of learning about, what's the difference between an LLM, semantic kernel, plugins, and AI agents, a little bit of terms there to understand. And really, what can an AI agent do that an LLM cannot do? Again, that's what got me interested in learning AI agents, is some of those capabilities I wanted to learn. So quick theory before we get into the code, the C# code. When it comes to the different components, the different pieces, I really found an analogy to be most useful. If you think of an LLM, that's the whole brains of the operation or the intelligence. Whereas the semantic kernel, now I know and most of you are familiar with ChatGPT, right? ChatGPT or Claude Code or Grok. There's many of these LLMs that are out there that operate as the brain, the logic, so on and so forth. Semantic kernel is something new. I'm going to come back to semantic kernel. The plugins that we're going to write, this is the C# code that we write that is the actions. Okay, so if you think of the brain as the LLM, the plugins, this is the actual code that we write that are actions. If this is a human body, think of your hands perform the actions, or your feet, or your eyes. Okay, the kernel is the layer in between the brain and the body that kind of controls the flow, right? If your brain interprets something, it's going to tell your hand to grab something or to release something. And so the kernel is the nervous system that acts as an intermediary between the LLM, that is the brain, and the plugins, that is your C# code. The AI agent is all of that together. My takeaway is that AI agents can do a lot of things that LLM can't because they're more encompassing. They're just a bigger entity. An LLM can be a part of an AI agent, but an AI agent really can be much more than just an LLM. So again, what can an AI agent do that an LLM cannot? This first bullet is why I got into studying AI agents. I understand ChatGPT, it kind of scanned the whole internet and it uses that as its data set. A past representation of all the data on the internet. And in the early days of ChatGPT, it was like 3 or 4 years old. Well, I got into this because you could see that the first thing that an AI agent can do is it can take real world action. It can execute code, execute your C# or Python. It can interact with systems. That's the bullet that I was into. It's like, hey, I've got a database. I want an LLM to interact with my database and answer questions about my customers or my database records. So an AI agent can interact with your database system, search and retrieve real-time data. So an AI agent can actually make an API call, right, that retrieves real-time weather data or real-time stock data. So again, AI agents can do much more than just what LLM can. AI agents can even have goals. Now, I've got a lot of learning to do around this, but there's something called the planner in an AI agent. We're going to see this in the code. There's a planner that allows you to set up goals. And that's, as a person, of course, we should be goal-oriented. Well, AI agents can have goals and take steps towards achieving those goals. And an AI agent can operate proactively, right? Instead of waiting for a user to give it a prompt, an AI agent can operate autonomously without a direct prompt. Okay, so you can see that broadly speaking, AI agents are just more powerful than LLMs. In fact, they encompass an LLM and can do more, like having goals. It can have memory, it can have long-term memory, it can operate autonomously, it can hit real live databases, get up-to-date information, hit your local database, in fact. So that's why AI agents are exciting. And so now, to build your first AI agent, I'm going to use Visual Studio Community. And so if you're familiar with this tool, it's got a purple icon down here. I got my mouse hovering over it. If you've installed Visual Studio Community before, if not, hit the website, visualstudiomicrosoft.com. Get the downloader just to show you when you run the downloader, you're going to need this checkbox for .NET desktop development. That way you can write the code that I'm about to write. You're going to need to install Visual Studio Community. If you're familiar with VS Code and know how to operate a terminal in VS Code, that will work as well. I just wanted to show folks who might not have Visual Studio Community downloaded, where to get it, how to run the installer, and what package to go ahead and click to download and install. I've already got it installed, so I don't have an install button. Okay, I'm going to come back to the next slide. So once you've downloaded and installed VS Community, this is nothing but a command prompt, a command line application. Now I've built more with AI agents, but this is how I got started as my progression of learning has gone. So here's VS Community, again, the purple Visual Studio. Let's create a new project, and we're just going to create a console app. And so I select C#, and let's go to Windows Console App. And I'll click on Next. And then I'm just going to call this Hello World SK. And where on my computer it goes is not super critical, but you could choose the hard drive location. Make sure you know where your source code is going. And .NET 9 is standard. .NET 8 is long-term. For learning purposes, standard is fine. Anything that's going to go into production should be long-term support. So it really doesn't matter. I'll just choose long-term support and spin up the command line template. And of course it goes to my other screen. So Computer Science 101, Hello World, C#, no big deal. Let's just go ahead and run the template so we get a little Hello World app that's running. And now we've got a place to start from. We get the Hello World response. Semantic Kernel is a dependency. It is a package that you can bring into Visual Studio. It's not built in by default. So let's delete what's there. and I'm going to go to the package manager off of the tools menu and bring in Semantic Kernel. Again, that's the nervous system, if you will, is the kernel. So let's go to the NuGet package manager and click on Browse, Microsoft Semantic Kernel. If I spelt it properly, this is the correct. It's already got 5 million downloads. So a lot of people have been working with Semantic Kernel. And once it's done, you're going to get the green check mark, and under your dependencies, you should see Microsoft Semantic Kernel. Now, that allows you to work with the C# classes that are in that package. Okay, but we have to essentially import those with our using statements. And so there's a few using statements that we will ultimately use for this project. And next up, realize that AI agents rely on an LLM. Okay, so there's a couple of options here. You can use Microsoft Azure OpenAI or go directly to OpenAI. I tinkered with both. I found it a little bit easier for me to go directly to OpenAI. So I would invite you guys to, at this point, go ahead and go to platform.openai.com. We are going to need an API key from OpenAI that will allow us to use their LLM. And so that's what we're going to do. So if you go to platform.openai.com, you might have to register, make an account, okay? And go ahead and search for API keys and create a new secret key. Now, of course, these secret keys are not anything I'm going to expose to the internet, but you can see I've made a couple of them already. Once you make one, once you make an API key, the next step, and again, it's a real simple: create a key, give it a name, and select the default project. Create the secret key. Right, so that's real easy to make a key. You copy that secret key, and then you're going to put that into what's called an environment variable in Windows. And so a Windows environment variable, if you click on Start menu, assuming you're on a Windows machine, Linux operators, you're going to set your environment variables differently. On Windows, you can literally search for environment variables for your account. Well, before I do that, environment. Normally it's a 2-click process, but when I search for environment variables, it literally takes me here. Okay, this is what I was looking for. And then I click environment variables. So it's a 2-click process. If you can get there in 1 click, even better. Okay, now I'm going to delete this Open API key just because I have already done this once. So assume that I haven't done it. I didn't have to click in delete on anything. I'm going to click a new environment variable. Now the name of it is important because we're going to reference this name in code. Okay, now in code, I call this, and it's all caps out of convention, OpenAI, if I can type, OpenAI underscore API key. Okay, now I'm going to pull this off to the side, but I'm going to paste in my key right here. Okay, that way it's just not going to the public internet. Okay, copy, paste, click OK. Now we click OK. Click OK again, and our environment variable should be set. That's all we need to do. Once you've set the environment variable in Windows, the important next step is to close Visual Studio because you have to reinitialize the terminal. Save your project, and if I just right click, I can reopen up my solution file. You can just reopen Visual Studio, but you must reboot Visual Studio. That's going to kind of reinitialize your terminal with the new environment variable. If you skip that step, it will not work. One last thing I should have mentioned, I can't believe I skipped it. One second, let me go back to the docs. Back here on the OpenAI, unfortunately, this is something that you will have to spend $5 on or $10 on in order for this to work. If I go to billing, you're going to notice I spent $10 and I've hit this a bunch of different times. My advice is, go ahead and spend the price of a Big Mac to learn this technology. Obviously, LLMs are expensive to operate. There's a lot of investment going in. So if you're going to use the LLM, they charge you a little bit. Spend $5, spend the price of a Big Mac. My current students, I can't obviously force anybody to spend money, but in my 2 cents, it's worth the $5 or worth the $10. So set it up under billing, just spend $10. That way you can check this out. Back to the source code. Okay, so what we need to do is we need to say, hey, what model are we using for our LLM? And so in this case, this is OpenAI's 4.0 mini model. So there's different models. You should be able to get by with this one. The next thing to do is to read that environment variable out of the Windows environment variable. So again, here, OpenAI API key. This is reading that environment variable into our local variable in C#. And then we get to create a variable for our what's referred to as our kernel. Again, that kernel is the system that operates the nervous system between the brain and the body. Okay, so we go ahead and create that kernel. We pass it our model ID and our API key. We then build the kernel. So build the kernel. Okay, so builder.build. So build the kernel. And because this is an LLM, we're going to have chat with the LLM, and we're going to have chat that kind of goes back and forth. They enable that with this interface called iChat completion service. And so in our kernel, we basically enable chat. Okay, so this is going to enable a little back and forth chat with OpenAI. Now I mentioned plugins. So here's, again, these are the different components. We mentioned the kernel component, and I mentioned the plugin. The plugin is where we're going to write our C# code, and the plugins were the actions. They were the eyes, the hands, the feet in our person analogy. Okay, so notice here, this is a plugin. We're adding a plugin to our kernel, and we have to create this lights plugin. So let's go ahead and generate the C# class and resolve that compiler error. And let's mark this as a public C# class. So I'll come back and kind of define what's in this plugin, but at least we get that working. Now I mentioned a planner that helps us with goals. I have a lot of learning to do with this. I'm actually really excited about this because I've used AI agents to query local databases, and I got that to work, but I haven't really set up goals. So I have a little bit of learning to do myself. Needless to say, kernels have a planner. Okay, so this next little chunk here is something that we're going to add to our kernel that's called, the planner. Now the rest of this is pretty straightforward C#. And so if you've studied C# before, you're going to have a pretty standard do-while loop. Okay, and just pause the video to write this code. But you have a do-while loop that has a string and builds a string. So we've got this user input string. And then we add that to the history. The history is a chat history object. And then here, this history object, we pass it to, ultimately, the chat completion service. So essentially, line 46 calls the LLM. We pass it our history, which is our user input, like whatever the user said. We pass it the planner, and we pass it the kernel. Okay, so into the chat we pass three things: the question from the user, or the string from the user, the planner, and the kernel. You're then going to output the results to the console. And then you're going to put that result in the history as well. So this history object is just a bunch of strings. It's a user string and a response. A user string, response. User string and response. When I'm saying response, it's from the LLM. Okay? So that's some pretty standard C# stuff. Nothing too unique there. Now let's go back to our Lights plugin. First off, again, this is the part that's cool about an AI agent, is that it can kind of work with local data sets. And so this local data set is just one of the pieces that's cool about AI agents. What is a light? What is a light plugin? Well, of course, you define that in a class. This is a pretty standard, C# class. It's nested within this Lights plugin. To me, the syntax is almost like you're not supposed to put a public class inside of a public class, but somewhere along the way, this became okay. Because back in the Java days, that was a big no-no. It's pretty standard auto-implemented properties to have an ID, a name, and is on. Notice the JSON property name. These attributes just make it a little bit more pretty for the end user. The output will be is_on as opposed to is on, that's one word, right? So this is a way to kind of format it a little bit nicer for the user. Now that we have a model, like what is our light, what is the thing, now we're going to actually make some mock data. So this mock data could come out of a database. In this case, we're just going to have a list of lights, and there's 3 lights in here. And they're auto-implemented IDs, names, and is-on properties, right? These are object initializers, right, to have a list of C# lights. Okay, now again, you can read this out of a database. This is just hello world getting started. If you're seeing this for the first time and you've never taken a C# class, maybe I should have said that at the beginning. This is really, kind of a 200 level thing. This is, if you've never studied a C# do-while loop, this is going to be well over your head, or a C# class, or a C# list. It's going to be well over your head. Okay, now we define the methods. What can this plugin do? This plugin can really do 2 things. The first thing it can do is read the light status, right? So if we kind of look at this function, it's called get lights async, and all this function does is it returns the lights, right? So it sends data back that is the lights. That's our data set. So again, making it readable, get lights. And when I asked the AI agent, what can you do? It responded with this description. It says it can get a list of lights and their current state, right? So the AI agent knew the behaviors that it could do based on these descriptions inside of the plugin. And the next thing that it can do, control this, paste this, is change the state of one of the lights. So here's a method to change the state of a light. It takes in the ID of the list ID 1, 2, or 3 in a Boolean true or false. It queries the light based on the ID and changes the property to true or false based on Boolean true or false that's passed in. Now what's crazy is that this plugin has two methods. I don't have to manually call these methods. This is all I had to do was wire up a kernel, right? I make a kernel and I tell the kernel to use the plugin, and then I call this chat completion service and I tell it to use the kernel that has the plugin, and it figures out what it needs to do, which kind of seems like it's thinking, doing some thought based on the LLM's brain is getting some messages to the kernel, and then it can determine what method to call. I never had to call this method or that method, and if I run, this is the working demonstration of the application. Oh, let's not have that semantic kernel. That was the old namespace that I had. Tell me what you can do. Retrieve a list of lights and change a state. Change the state of a specific light. Change the porch light to on. I don't know what its state was. Sometimes it understands prompts like one, sometimes it doesn't. So tell me the state of my lights. These are my smart lights. Be smart about it. Porch light is on. Turn chandelier off. It's going to call that method for me. I didn't have to do that. It's not the most impressive application ever. It is Hello World, but this Hello World is the smartest Hello World I've ever built. So I'm really excited to continue to learn semantic kernel, Microsoft Semantic Kernel, and AI agents. I hope you are too. Please let me know what you guys think.